Welcome, dear friends, to Saitechinfo, your gateway to a world of knowledge and inspiration. Let us navigate the fascinating realms of knowledge across the 4S pillars: science, society, spirituality, and sustainability. Science. At Saitechinfo, we are more than just a YouTube channel. We are your go-to destination for a diverse range of content that caters to the curious minds of coaching school and college students. Our commitment extends beyond academics as we provide invaluable career guidance and counseling to help you navigate the path to success. But that's not all. We specialize in corporate training, delving into the fascinating realms of coating technology and advanced smart materials, including the revolutionary world of nanomaterials. Our mission is to equip you with the skills and insights needed to thrive in today's fast-paced world. Saitechinfo is not just about education, it's about empowerment. We create engaging concept videos that span the spectrum of science, technology, engineering, mathematics, medicine, and management, a holistic approach to nurturing well-rounded individuals. Society. But our journey doesn't stop there. Saitechinfo is committed to shedding light on societal matters that shape our world. We engage in meaningful conversations about the interconnectedness of individuals and communities, fostering a deeper understanding of the world we live in. Spirituality. In the pursuit of knowledge, we recognize the importance of delving into the spiritual dimensions of life. Saitechinfo invites you to explore the enriching world of spirituality, encouraging introspection and a harmonious connection with the inner self. Sustainability. And as stewards of our planet, we champion sustainability, recognizing the urgent need to preserve and protect our environment. Join us as we discuss eco-friendly practices, cutting-edge technologies, and sustainable solutions to create a better future for generations to come. Saitechinfo, where science meets society, spirituality, and sustainability, fostering a holistic understanding of our world. Your support means the world to us. Subscribe, comment, and share our content with your friends and relatives. Your encouragement fuels our passion for content creation. For those seeking a deeper dive into premium courses, connect with us directly on our Telegram channel, Saitechinfo, or WhatsApp to 9444929163. Join us on this exciting journey of exploration and learning. Saitechinfo, where curiosity meets knowledge and inspiration takes flight. Subscribe now and let the adventure begin.
Hi friends, how are you? In this technical series, I'll be explaining about how to make the paint. So this will be very interesting for young entrepreneurs. Before taking up this project, you should be aware of the choice of paints. For example, as far as wall paints are concerned, you have to choose exterior or interior paints. Before taking up any surface coatings, we should be aware of the substrate where we are going to coat. Likewise, based on the substrate, we can have variety of paints. I have listed a few here: exterior wall paints, interior wall paints, enamels. Enamels means that is dry air drying enamels in this case, because we have got stoving enamels also. And then we should be aware of the cheap putty paints. So these paints are applied after the primer. Let it be the metal surface or the concrete surface or the civil structures. we need to fill up the pits or any surface undulations with cheap putty paints. And this is applicable for wooden surface also. But as I already mentioned, for different substrate, we have to use different types of paints. Then primers followed by finishes. What's the difference between primer and finish? Primer consists of extenders in larger ratio, whereas a finish, it consists mainly the pigments. After all, paint is nothing but pigmented varnish. Pigment is nothing but the coloring agents. And we should know something about the paint accessories also. Then, is it water based or solvent based? So these things are very important. And as far as the solvent based paints are concerned, we need to take care of the safety aspects and the environmental aspects. Now let us talk about the uniqueness of this project. Suppose if I take the water-based emulsion paint, water being the universal solvent, it should be available where the paint industry or this project is to be started. And we should cater the needs of domestic market. And as far as internal customers are concerned, suppose if it is done by or if this project is initiated by any that is government organized small groups, that is self-help groups, probably the government themselves can support with their procurement for finishing the government buildings, school buildings and highways. As far as highways are concerned, that is you should know something about the road markings and the safety markings on street, etc. And by starting this small scale self-help, that is manufacturing units, you can generate the employment locally. Now let us talk about the raw materials. Pigments, as I already mentioned, they are imparting, that is giving colors. After all, when a paint is applied on a surface, it has three purposes. One is decorative purpose, second is protective purpose, and there are other uses like functional purposes also. For example, when I paint a tar road or any trees on the sides of the road, the tree does not require any color, but whenever vehicle's headlight falls on that tree, particularly this white or black and white or that is luminescent coatings, they immediately reflect so that we can drive our vehicle safely. And let me come back to the raw materials, emulsions and polymers, extenders. I am talking about here that is water-based paints, where they are applicable on civil structures. Then extenders. Extenders can be called pseudo pigments or false pigments, like china clay. Then you've got titanium and not titanium. Titanium is a true pigment, whereas extender is a false pigment. So in order to reduce the cost of the paint, we can incorporate such type of surface fillers. So these extenders may be some, as I already mentioned, china clay, soapstone, etc. Then the paints may require some additives, and as we all agree, water is the universal solvent, so the quality of water is also very important. And we need to add some monomers and some diluents. So these are the major raw materials to manufacture some water-based paints like emulsion paints, distemper paints, etc. I am here focusing only the that is water-based paints. So probably that is I would have mentioned or highlighted with blue color. Okay, we are not touching up on the enamel paints and other types of paints, but we'll be discussing about water-based paints that can be applied on civil structures. Then, water-based paints. What could be the process? After all, water-based paints are manufactured with the major process called the dispersion of pigments and extenders. So, the dispersion is grinding into a paste and finally it is made up to the required volume. And the major pigments are titanium dioxide and the required color pigments. Then we need to add some extenders also like talc, which is nothing but soapstone, then calcium carbonate, that is calcite, clay, etc. And as I already mentioned, these extenders are surface fillers so that it can fill up the surface. That is, if the surface is rough, it will smoothen. And then, in fact, that is the main objective of application of paint is to hide the surface, is it not? Then, and therefore the opacity is a very important term to be considered. Then, mixed in water under vigorous agitation. So this is called the pre-mixing stage. So all these pigment extenders and part quantity of that is emulsion should be mixed under vigorous agitation using a proper premixer or premixing unit, and followed by that is it should be finely ground, preferably using sand mill. We have got different machineries based on the requirement of the type of paints. Then the slurry is further diluted by adding emulsion and water, and it can be thickened up by using proper thickening agents so that we can attain the required viscosity. And then we need to obtain the required physical parameters, that is very important. The final paint is filled in containers and dispatched. So this is the simple story or the process about the manufacturing of any emulsion paints, let it be exterior or for interior. And then, see, now let me go in detail about the process. Here, the raw material should be properly tested because the quality of the product depends on the quality of the raw material you are going to use. And then it should be properly stored also. Then we need weighing and the transfer of appropriate raw materials into the mill. Then the dispersion and grinding operation. And then we need to stabilize the dispersion. And the dispersion is pumped into the blending or the mixing unit. Then we need to incorporate other additives by using that is a proper additive or the suitable agents, and these additives are added in small quantities to provide a particular property to the paint. For example, if the paint is too thin, we need to use a thickening agent. If there is any bubble or foaming, we need to use the anti-foaming agents. So likewise, we have special chemicals which serve the purpose of a particular parameters of the paint. Now, tinting is nothing but attaining the required color by using the stainers or tinting agents. Then, the samples should be taken for color evaluation and analysis, And we need to check other rheological properties of the film also. Then finally we have to check the viscosity and density. Then we need to add additives as I already mentioned, then dryers if necessary to meet the viscosity and drying specifications. And then the material is strained and filtered for a better standards. Then it should be filled into cans, and then the product is gravimetrically or volumetrically filled into cans and should be labeled. Finally, it is kept in the storage or in warehouse, and it should be ready for the dispatch to the customer. So this is the entire process about the emulsion paint. Now let us check this. A flow diagram is a simple one. Here you can see this is the high speed dispenser where we add the powders, then additives and water, then all these are mixed, and again it is fed to the another mixing unit, and where that is you may use here the sand mill also after pre-mixing, and appropriate grinding is taking place here, and after that the viscosity is adjusted by transferring this into a making up tank, and after tinting it is ready for the filling. Then the key stages of manufacture: pre-mixing, dispersion, mixing and filling. So pre-mixing to facilitate the grinding, dispersion is mixing and grinding, and mixing is to add this is the important stage where some of the additives are added to attain the required properties, and also we need to adjust the viscosity of the end product. Finally it is ready for filling. Then let us talk about the dispersion. So we have measured quantities of raw material that should be ready with the weighing scales. Then pigments, extenders, water and small additives are added as per the formula. And then the dispersion equipment, which is nothing but the high speed disperser, is used for mixing and grinding the paint. Finally, we are able to produce the slurry, and the disperser is run for specified time as required by the recipe, because we need to attain the grinding level. So usually it is represented in Hegmont units. Then the finish and the particle size distribution of the slurry is checked with the grindometer. Then finally the slurry is transferred to the mixing tank, and the mixing tanks are intermittently agitated and proper coloring is achieved here. Then the balance emulsion, resin, water and other additives are added into the mixer as per the formula. Then the mixer is run for specified time as required by the recipe to prepare the paint, because based on the different types of pigments and extenders, we need to judge the grinding time and the grinding level also. Then the density, viscosity, strength are checked in the laboratory, and this is the continuous, the regular process of quality checking. And finally the paints are filled. Before that it should meet all quality parameters, and they are filled into the containers with the different pack size: 250 ml, 500 ml, 1 liter and 4 liter, 20 liter, 10 liter, etc. And the weight to volume conversion should be made here, because you may work out all these things based on the weight, and finally you will be selling as volume. So the weight to volume conversion is very important. And then quality standards. When we talk about the quality standards, we need to know, be aware of these British standards, 15489, 2004 for this kind of acrylic paints, and type 2 for acrylic paints. Then wet opacity, drying time, finish color, alkali resistance, then scrubbability, wet scrubbability, and overall look and feel of the paint should be checked. And then normally ordinary paints may range from 90 rupees per liter, even that is it may go up to 650 rupees per liter. High sheen paints it may cost 120 rupees per liter and maximum 600 per liter. And enamel paints 200 rupees per liter and maximum price may be even 800 rupees per liter. The price factors are very, very important. They are based on the type of resin you are using, pigments, the type of pigments, pigmentation, that is how much pigment you are using, and the quality of resin as I already mentioned, then additives and solvents. And then let us talk about the cost inputs. That is, the land is a very important aspect. That is, what is the area you are having, then production capacity, machinery and required equipments, then raw materials, then intermediates, manpower, sales overhead, power, safety, environment standards, technical know-how, logistics, and profit. All these are the cost inputs. Then when we talk about the implementation schedule, probably that is we need to select the appropriate site and get the approval from the government. Then preparation of the project, it may take 1 to 3 months, and a provisional registration, it may take another one week or 2 weeks, and we should be ready with the financial budgets. It may take 3 to 6 months. Then we need to procure the machinery within 5 months, and we will install the required machineries and other setup, electrification, then commissioning of machinery, all other facilities, and that will happen within 3 months. And finally, we should get the no objection certificate from Pollution Control Board. So all these are very, very important in the implementation stage. The budget, probably that is the lowest budget, maybe 3 to 10 lakhs, and moderate budget we can have 15 to 60 lakhs. Then standard budget is 3 to 20 crores. High level budgets with full automatic machinery setup, it may cross even 30 crores. And to start with our young entrepreneurs, they can start the paint unit even with the lowest budget of rupees 3 lakhs, 3 to 5 lakhs. And finally, I should talk about the safety and environmental standards. So you should have the proper firefighting system and first aid. Then you should educate your workers how to handle the raw materials, intermediates and products. Then we should be aware of handling the machineries. Appropriate training is required here. Then material safety standards, safety MS, used to say that is MST, product data sheet and material safety data sheet. All these things should be provided. And then the water should be pre-treated so that it can be effectively utilized in our paint making, and as well you should be post-treated before letting this into any gutter. So that effluent part is very important, effluent treatment. And then waste management, that is how to handle the solid waste, liquid waste and semi-solid waste. So proper training should be undertaken in this aspect. Okay. So I hope you should have enjoyed this video training. And if you are very much interested to start your paint unit, you can contact me in the comment column, and based on that, I'll be able to give you my online recommendations. Thank you for watching this video. Hi friends, welcome to my technical training series session. In this training, I'll be explaining about the small scale manufacturing opportunities in paints and allied chemicals. Let us have the overview about this training session. Here we'll be discussing about the importance of paints and coatings. Then what are the different surfaces where we can give the coating? What are the types of coatings? Then what are the machineries available for manufacturing in a small scale of paint? Then I'll be discussing about raw materials essentially required for making a paint. And then who are the important customers who are looking for such type of coatings. Then let us have the discussion about the latest trends in coatings. Then I'll be explaining about my consultancy services. And finally, what are the opportunities we are offering under project training for entrepreneurs and research associates. Now, let me brief about the importance of coatings. There are three purposes of coating. One is decorative purpose, second is protective purpose, third is functional purpose. Now let me talk about the decorative purpose. So when you want to give a coating or painting on any substrate, let the substrate be a civil structure, a wooden surface, or a metal article or component, even plastic, whatever it may be. Any component, any machinery, any article that requires some aesthetic value. So, by giving suitable coating with some decorative values, you can improve your value of the products. Secondly, protective purpose. So, can we stop with just decorating the components with attractive colors? No. It needs to protect the surface as well as the component. So when we talk about protection, that is, our components must be resistant to, first of all, corrosion if it is a metal component. Then it should be withstanding temperature, humidity, water, etc. So all these are very important properties to be looked into. So we protect the surface by giving suitable combination of paints. Finally, there are some functional purpose also. For example, you would have seen black and white paints are painted on the trees of the roadside trees of highways or any road. And also you can have the zebra crossing marked with white or yellow, and sometimes they are using some reflective, that is luminescent, fluorescent coatings, etc. So what is the purpose of applying such type of coatings on in traffic signal? It is meant for, that is, guiding the travelers, drivers, etc. And there is one more functional purpose I would like to share with you. There is a paint called sound deadener. Actually, it serves the purpose of reducing the sound by vibration. In those days, there were so many metal components, particularly in large vehicles like bus, lorry, truck, etc., where near the wheel part there will be lot of vibration. So we used to apply the coal tar based sound deadener, that is to reduce the sound, and that is applied inside the metal sheet. So that is one of the function purpose of paint. I hope now you should be very clear about the three purposes of any coating. Now let us move to the next one. What are the different surfaces where the paint is applied? So we got the metal surface. It can be ferrous metal or non-ferrous metal like brass, bronze, copper, aluminium, etc. But we don't paint on gold, After all, gold is a royal metal, inert metal, so it does not undergo any oxidation. Whereas other metals which have the tendency to undergo oxidation and thereby forms a rusty layer, that should be protected. As in the case of iron, So we have got huge structures of bridges and monuments, etc., where we need to protect the iron surface, iron component from the aerial attack, moisture attack, so that we can avoid rusting. So, in those cases, that is, we have to be very, very careful about the choice of primer as well as paint. So, it should be anti corrosive. So, that is the very important one. And over which we apply the finish coat so that it will give an aesthetic appearance. The look and feel will be better. Now, let us move to wood. Even wood surface that requires a very neat paint. Some people, they simply, even let it be teak wood, they will apply some solid finishes. For that I am not agreeable, because if it is some teak wood or Burma teak or rosewood, etc., we need to apply varnishes, that is pigmentless coating, so that we can enjoy the beauty of the wooden strains. So there is no meaning of simply applying any paint on wooden surface. So in that case, the clear varnishes are very popular as far as wood surface is concerned. Let me talk about, of course, that is, I should that is inform you about the varnish. How the varnish can be defined? It is a paint, but it doesn't have pigment. What is the role of pigment? That is, it gives opacity. It hides the surface. It hides the bare surface. But when we hide the wooden surface, wooden, what do you call those beautiful patterns, then it will be looking ugly, and that is not agreeable also. So in that case, we apply the varnish without pigment. So a pigmentless paint, that is resin with suitable additives and solvents, diluents, etc., can be called varnish, is it not? Right. Now, at the same time, we can also explain or define that is paint, solid paint. Solid paint is nothing but pigmented varnish. That is, you have got the varnish. Varnish is nothing but resin. That is, resin is nothing but polymer. The very objective of applying the resin or polymer is, when it is in the can, it is liquid, it is in the liquid form. When we apply over the surface, then it forms a lot of cross-linking of polymer, so that we are able to get a uniform fill. Now, let us move to the civil structures. So, on civil structures, we have got a variety of paints. For example, when we talk about the civil structure, we should be very careful about the choice of paint for internal surface as well as external surface. For exterior coatings, it should be weatherproof, weather tough, okay. And the major, there is an enemy for any building is water. So you should arrest the leak. It should be water resistance. It should be UV resistant. Okay. So in such a way, we have to select that is proper paint for exterior walls or exterior surfaces. Now, let us go for plastics. So the raw plastics will look very ugly, So instead of that, we can give a beautiful coating on plastics. When we talk about plastic, we have got variety of components which have been made up of plastics. Nowadays, even automotive industries, they replace many metal parts with plastic in order to get them better mileage of their vehicle. Now, even the glasses are coated with different types of paints, where the adhesion is a very important parameter, and the etching is done before painting the the glass surfaces. Now let us move to the next aspect, the types of coating. So when we talk about the coating, first of all, we need to give some pre-treatment. Let it be metal or non-metal or wood or anything. It should be properly treated, that is pre-treated before coating, before going in for coating. So there are so many chemicals which are available for metal pre-treatment. I'll be discussing about this separately. Then primers for metals. So once the pre-treatment is done, we can give a coating of primer so that the surface can be smoothened and the consumption of paint will also be less. So this is applicable for metals, wood, cement, plastics, glasses, etc. Now, let us move on to finish paints. Of course, when we talk about the primer, above which there is one more coating called primer surfacer and putty paints. So when there is any dent, we need to cover that surface. So all these surface imperfections can be managed by giving suitable primer surfacer and putty. Now, let us go for the finish paint, and as usual the finish paint will have very attractive colors. We have got wide range of colors. Then clear varnish, as I already mentioned, this is designed for wood, sometimes for candy type of finishes, that is even on metal components we are giving some glaze coat, that is clear coat with very high gloss. Okay, then candy finishes. Candy is something like a very that is attractive colors, and it is made up of that is some colorful dyes, and these colorful dyes will be covering as a top coat over the metallic surface, that is metallic coatings, so that you will have a candy appearance. So in candy finishes there will be metal base coat followed by transparent or translucent colored dye based coating. So that is called candy finish. And metallic paints, some people they are crazy of metallic luster, so we have got variety of metallic paints based on aluminum paste. There are two types of aluminum paste available, leafing and non-leafing. So based on the requirement we can use different types of aluminum paste, and we have got some gold like metallic powders, then that is pearlescent finishes, etc. And above all that, now we need to go for a polishing also. So we got fantastic metal polishes. Okay, then before, if there is any maintenance coatings, we need some paint strippers. If we want to remove the old paint, that is we need to use the paint stripper. And now I will be finally discussing about the nano coating. This nano coating can be given in the pre-treatment, that is as a metal pre-treatment chemical, as well as the top coat clear. Okay, so we will discuss in detail in the subsequent slides. Next, as I already mentioned, the types of coatings can also be further classified as, that is water-based emulsion paints, then water-based pre-treatment chemicals. Then we have got air drying enamels, where by oxidative drying the paint is drying, that is by trapping the oxygen available in the atmosphere, the linear polymer of the liquid paint gets cross-linked so that it forms a smooth film. And then lacquer, that is by evaporation of solvents. Naturally these are all NC based, nitrocellulose based, then acrylic based lacquers are available, and they are drying by, they are all quick drying for automotive refinishes, that is in garages such type of lacquers are used. And there are one more type of paint, they are called stowing enamels. These paints that is essentially made up of some melaminized material. So here it is a kind of thermosetting resin, and by applying heat alone it gets dried, and that is why it's called stowing enamel. So it has to be stowed, these coatings should be stowed, that is baked. That is, there are so many types of stowing enamels. There are some high baking enamels and low baking enamels, then moderately baking enamels. Even from 70 degree to 80 degree there is a type of low baking enamel, and normally moderate baking, that is around 100 to 120 degree. There are some high baking like about 200 degree, and there are some heat resistance paints also, and in fact that is they get dried by the, that is a performance. For instance, these paints can be applied on the that is the heat engine part also, that is the exterior part, and two catalyst curing paints. So here the paint is dried by combination of the hardener and finish. You would have heard about these epoxy finishes and polyurethane finishes. So they are after all made up of two components or three components depending on the type of system. By mixing properly in the given ratio, we can attain the drying and better performance. Now let us go back to the resin system. So we have got different types of resins like alkyd based resins, NC based resins, nitrocellulose, then acrylic lacquers, acrylated alkyd, then stowing enamels that is melamine based urea formaldehyde, melamine formaldehyde, etc. And we have got some thermosetting acrylics also, then epoxy and polyester, finally polyurethane. And we have got water-based dispersions like polyurethane dispersions. They are called the latest PUDs, PUDS, polyurethane dispersions. Okay. Then, now let us talk about the machineries required for making any paint. Normally, we need a mixer and ball mill. It will be a cylindrical one by cascading that is a ball, that is steel balls and pebbles are available. These are all the different types of grinding media based on the type of paint, that is this kind of coatings are given. And that is filling machines. So once the paint is ground, it has to be properly made up. So we have got various types of mixing tanks, and followed by that, and even when we talk about the grinding media, there are so many types of grinding media available. Then attritor is a very good machine required for making any kind of paint. Then pug mill is designed for putty paints. Then after making all these paints, we had to fill up suitably with some sealing arrangements. So we have got filling machine, packing machine, and we should have some heating ovens, and any paint industry should have some small laboratory setup. Then we can have the major raw materials like these are all only categories under which we have got enormous types of raw materials in any paint. For example, pigments. It can be white pigment, colored pigment, and basically white pigments are titanium dioxide, rutile, and anatase. So titanium dioxide anatase paints are very much used as a cheap paint or wall paints, whereas titanium rutile, it has got better opacity, hiding power, and they are used in superior enamels. And we have got other colored pigments based on chromates also. Now let us move on to extender. Extender is nothing but a false pigment. Okay, so it means it just fills up the surface, that's all. It acts as a surface filler. That is, it can reduce the cost. And in fact, that is in primers and surfaces and putty paints, that is, we are using these extenders very much. Then that is a varnish and resins. So we have got various types of resins. Then solvents, petrochemical solvents, they are the major solvents, and then additives. So when we talk about additives, we have got special additives. Additives are the chemicals which are added in very small quantity so that it will serve the particular purpose. For example, if you want to make a yard drying enamel, we need some dryers. For example, there are so many types of dryers available. We call it primary dryer, secondary dryer. So these are all octavates of some metals like lead. So lead octavate, then that is manganese octavate, cobalt octavate. So these are all the different types of dryers. So similarly, there are so many additives. For example, paint have the tendency to undergo skinning. That is, there will be some dried layer formation at the top. So in order to avoid that, we have got some anti-skinning agent also. So likewise, we have got so many additives. And then now let us look at the customers who are very keen on this paint manufacturing, paint products. For example, we have got the domestic product like civil constructions, architects, then we have got carpenters, then monuments, malls, amusement parks, religious places like temple, mosques, churches, then swimming pools. All these people are in great demand of paint. They are in great requirement. So you cannot simply avoid any paint, because paint and cement, these are the two fundamental materials in modern world. So anyone who has invested money in manufacturing will definitely get huge benefits, and they cannot be losers in this market, provided they operate it in a very systematic manner under proper technical guidance with sincerity. Then industrial markets. So we have got automotive industries, plastic manufacturers, component manufacturers, container industries, engineering industries, chemical industries, electronic equipment manufacturers, even that there are so many manufacturing units. These are all OEM people. They are badly in need of very good quality paints. Then technical know-how. So we have got the technical know-how for nano coatings. When I say nano coatings, it is used for undercoating, that is a metal pre-treatment, where we call it nano ceramic coatings. So recently we have done some researches and come out successfully with a patent at University of Madras. You can contact us, and with the University of Madras, we will be able to help you also. Then candy finishes, then texture finishes, hammer tone metallic finishes, matte finishes, heat resisting coatings. So these are all my personal researches and experience I have acquired by serving in many paint industries. Then flame retardant coatings and water repellent coatings. So our consultancy services are paint formulation, metal pre-treatment, chemical formulations. Then we undertake turnkey projects for nano coating and powder coating plants. Then troubleshooting is being done in surface coating. So in any OEM people, if they have some problems in finishes, that is surface coatings, they can very well approach us and get our expert opinions, so that they will be able to come out of the defective coatings, and they can standardize the specifications of the paints also. Then we undertake a project training for entrepreneurs, companies, and research associates. So we give e-learning training, we give short-term certificate courses also. Then we undertake project training for research students, and if there is any doubt, we conduct doubt sessions through Telegram, and we regularly conduct live sessions in Google Meet, for individuals as well as for group of trainees. And we also undertake corporate training at their premises. So for everything, you can contact me in this phone number given, email address, and also kindly visit our website saitechinfo.com. Thank you very much for watching this video. Actually, we have two types of paints. One is the aqueous paints or emulsion paint, that is water-based paint. Another is the oil-based paint. So when we grind these two types of paints, the device, the machinery, the grinding procedures are totally different. Now, we are going to focus more on the oil-bound paints, that is non-aqueous. Aqueous means water. So non-aqueous, okay, that is water-based paints. When I say water-based paints, it is applicable on, it is called emulsion paint. It is applicable on wall surfaces, okay, architectural paints you can call it. And when we focus on the oil-based paints, that is, as I suggested, we need to consider the non-aqueous. Non-aqueous means without water. That is, it is not compatible with water. That is a fully oil-bound paint. Okay. In the case of aqueous paint, that is emulsion paint, the problem of the emulsifying, then there will be a problem of that is the aeration. There will be a lot of bubbling also, air bubbling. So this will confuse the paint system. Okay, so let me throw some light on that, and we'll come back to the oil-based paint. Okay, right. So in the case of emulsion paint, we'll be using the same wetting agent, dispersing agent, flow agent, but there will be leveling agent. Along with that, we had to add defoamer, deaerator, and anti-settling agent is a common, but based on the resin, the nature will be different. So these are all the cases in the case of emulsion paint. So here the anti-settling and dispersing agent, they support actually the paint and the pigment dispersion, that is mixing of these in a proper manner, and it should produce a stabilized emulsion. That is very, very important, and also the dispersion solution. Otherwise what will happen, this emulsion will break into two layers and the properties will vary and it will result in defective paint. So in the case of emulsion paint, we need to add defoaming agent necessarily. If there is too much of foams, then the processing problem will be there and there won't be proper mixing at all. So that is why we need to add defoaming agent in the case of emulsion paint. For instance, we need to add silicone or non-silicone based defoaming additives, and they are all generally used in latexes. Latexes means emulsion, and they are required in small dosage only. In fact, all these additives are the reagents which are added. These are the chemicals which are added in very small quantity to serve a particular purpose in a paint, and they contribute, actually this kind of a defoaming agent, they contribute improvement in the brushability, so it will not stick onto the surface, and the nil bubble effect gives a uniform paint film on the surface of the wall. You know very well, oil and water are immiscible, is it not? So we have to make it miscible by introducing a third agent, and that is called soap, which is also known as emulsifier. Soap is an emulsifier. So as we already discussed in the previous video, that is, you have, let me consider a test tube. In the test tube, we take, that is oil and water. They are immiscible. But if you want to make it miscible, you just add a small amount of soap powder. It becomes emulsion. So it is thoroughly miscible. So the role of soap is, that is, it binds the oil and the water into a uniform mixture, and that results the emulsion. And so here the frothing and the foaming, they are detrimental to the process as well as paint film. So we need to add this emulsifier along with the defoamer only. Now let us try to understand the role of defoaming agent. For example, so here you have got water and oil. As you know, that is that they are totally immiscible, but by adding the, that is what you call the emulsifier and along with the foam additive, it break into pieces so that you can avoid the film form, the bubble formation. So here, and this is the foam control additive. This yellow part is the foam control additive, which is nothing but the silicone based additive. Now you just assume if there is no such that is yellow part, that is foam additive, what will happen? It will form a spherical bubble. So the role of this addition of foam control reagent is to break this bubble. So it will elongate and break the lamella. It is called the rupture of lamella, and thereby, that is, you are able to get the uniform, that is emulsion without foaming. So that is very, very important, and this is the mechanism of a defoamer action. And actually the defoamer penetrates into each bubble and breaks it. So the role of defoamer is very very important in the case of emulsion paint. So it works by breaking the water surface tension, and it is very suitable for cooling, boiler and effluent water treatment also. So this kind of anti-foams are used not only in emulsion paint but also in coolant, that is boiler coolant and even effluent water treatment. And there are some food grade that is silicones also available, and they are used in the food based anti-foam emulsions and drugs also. Okay, and once we add the defoaming agent, such kind of bubbles will be definitely suppressed, and it will result a uniform, very decent, good looking emulsion. Now let us talk about the settling of paint. So in this case, on the left side you can see there is a settling of solid pigments, whereas here, that is during the pot life or shelf life, there is no such settling. It is because of the proper incorporation of anti-settling agent. Okay, so settling is a big issue. In fact, most of the paint making people who do not know the basic knowledge or the chemistry of a paint or the settling or anti-settling aspects, they will definitely end up such kind of defective paint. But if you are a good paint manufacturer with proper background, academic or technical background, you will get a beautiful product so that you will not get any problem with your customers. Now, if the pigments are not uniformly wet, this kind of settling takes place, and that is why we must avoid such settling by using suitable anti-settling agent, and this must be added in the grinding stage itself. That is very important. And not only that, there will be a kind of flooding or floating. Okay, so flooding floating means if you have got a blue color, a blue pigment and white pigment, so the blue and the white will not be mixed properly, and you can find a lot of white streaks in blue or blue streaks in white. So this is called flooding, and this should be that is nullified by adding anti-flooding agent, which is nothing but silicone oil once again. Now you can see this is called a floating, that is flooding defect in paint. This is the paint film where you can see lot of floating, and here, and that is responsible for discoloration or that is disproportionate coloring also. So in that case, once we add properly, then you are able to get a uniform smooth finishes. Okay, so this is A is floating and B is normal, and C floating is converted into flooding after silicone oil is added, so it yields an effective smooth finish. Now when we use some combination of coloring matters like pigments, there is no uniform mixing of pigments. So this do not, in fact, that is you should not add this anti-flooding agent. That is you will if you do not add anti-flooding agent, what will happen? You will not get the true color of the pigment. Okay, so the true color is very very important, and in order to obtain the true color, original nature of the pigment, this kind of flooding agent, that is anti-flooding agent, should be added. So this involves in elimination of color separation, and thereby you will get a natural color. So dryers are generally used in air drying enamel paints, and we will discuss in the subsequent video about the dryers. When pigment volume concentration is less than the critical pigment volume concentration, we are able to get glossy finish because the binding portion, the binder portion is more. When pigment volume concentration is greater than critical pigment volume concentration, that is in this case, we have lot of gaps or empty structures due to an insufficient polymer. compared to the pigments. So the presence of air may cause loss of local connectivity. That is, the binder loses its continuity. That results the change in the property of dry coating. It means there is an increased porosity. So this results the matte finish or satin finish. Matte or satin finish. And that is why such type of coatings are recommended for indoor applications. When PVC is equal to CPVC, it results a continuous form. It means the pigment is soaked in the right amount of polymer to fill the gaps between the particles. And the polymer and pigment are correctly interconnected in order to form a continuous film. So based on the PVC, we can have different types of finishes. Now let me discuss about the pigment volume concentration, that is in terms of percentage for different types of coating. Here this is the type of coating. This is the PVC. For automotive clear coat, the pigment volume concentration is less than 5%. Almost there is no pigment at all, but even then you can say pigment volume concentration. And for the high gloss white top coat, high gloss white top coat, the pigment volume concentration should be 15 to 25%. And for anti-corrosive primer, so anti-corrosive primer, it will be 25 to even 65%. And for interior wall finish or matte finish, matte wall finish, it will be greater than 85%. So this is the way you have to judge our pigment loading in a paint. In fact, in the low PVC formulations, the binder, let me consider the binder matrix. So this is the low PVC. So here the pigment particles can be here and there, low PVC. And you can find the distance between them is larger. Are you able to follow? And this is the binder matrix and this is the pigment. But in the case of high PVC, there will be large amount of pigment with shorter distance. So here the pigment, that is the distance between the pigment is less, longer, large distance. and here it will be much closer, shorter distance. Okay, and these are all the pigment, and this is the binder or medium. And let me explain about other parameters. I mean, what could be the consequences if there is a problem with the PVC? It results as the paint defect. Let me consider, see, here we have the optimum level, and the gloss will be reduced like this by loading the pigment, and this is the critical pigment volume concentration, CPVC. And when the pigment is more, let me say we have got some pigment, and we have some binder. Okay, and this is the range of the critical pigment volume concentration. Here you have some pigment like this, and here the pigment concentration is more. Okay, the pigment concentration is more here. Here less. Okay, now listen. So this is the pigment concentration, PVC. From left to right it increases. So in the lower case means there will be less pigment. In the higher case there will be more pigment. It crosses when it crosses the critical pigment volume concentration, now what happens? The gloss is reduced like this. This is the gloss. So by increasing the pigment volume concentration, when it exceeds the CPVC, the gloss is reduced like this. So if you want to improve the gloss, you have to reduce the pigment, but increase the solid content of the binder. And CPVC is the critical. This limits the dosage of pigment, and here more amount of pigment. So as we go from left to right, the PVC increases, and if there is more pigment, means it results in voids. Are you able to follow? And there will be more permeability. So with the increase of pigment, there will be more permeability of paint or film. And this may cause, in the case of regular paint, if it is more, means now this will also cause blistering. So here the blistering takes place. Blistering means that is something like that is burst open of film. The film is looking like you will have some crocodiling effect also. Okay, so I think this would be the best illustration for explaining the PVC and its impact on glass and other paint defects. Suppose if it is too matte, means there will be water permeability. It will absorb water, it will absorb oxygen, it will absorb the air from the atmosphere. Okay. So low PVC means the transparency will be more. So this is the lower PVC part and this is the high PVC part. So lower the PVC, higher will be the transparency. Therefore, CPVC is the limiting factor. for a normal paint. Do you understand this? I'll share with you the blistering part of it. You just look at it. This is the blistering. Okay, blistering of paint. Now we have come to a very crucial point of formulating the paints, and what are the important parameters to be considered in paint formulation. Pigment binder ratio, so this is a very important one. Then solid content, that is also called non-volatile material, that is given as percentage. Then pigment volume concentration and the CPVC, critical pigment volume concentration. And we should know about the viscosity, specific gravity. Then based on that we have to work out the costs of our formulated product. Let's discuss one by one. Pigment binder ratio. So here the pigment, when I say pigment, we have to consider the weight of the pigment, and also it may contain some extender, so you have to include that one also. So it is the total weight of the pigment and the extender divided by the solid content of the binder. So that gives you the pigment binder ratio. I will work out all these parameters by taking one sample formula. Then solid content, this is nothing but the weight of the non-volatile material present in the paint divided by the weight of the paint we have taken into 100. So how it should be taken, I will detail everything in the experimental part. Third, the pigment volume concentration, about which we already discussed, which is nothing but the volume of the pigment. How can you get the volume of the pigment? After all, it is the pigment in the solid form. How can you get the volume? We can work out based on this. For example, we know the density. So density is equal to weight by volume. If we know the density of the pigment, by knowing the weight, we can calculate the volume. Therefore, volume is equal to, that is, weight divided by the density, based on which we can calculate the volume of the pigment, into 100 divided by the total weight of the pigment and the non-volatile binder. We have to consider only the solid content of the pigment, binder. And so this is a very important parameter in paint formulation, and describes the quality of the paint also. And here the PVC affects the following parameters like gloss, opacity, durability, rheology, that is the settling characteristics, washability, even water resistance, water permeability, etc. Then we know already the pigment volume concentration vary for different types of paint. For example, in the case of matte paint, it is around 50 to 70. And for specific semi-glossy paint, it is 35 to 45. Then high glossy or glossy, 20 to 35%. And for exterior house paints, it is 28 to 36%. Metal primer, it should be 25 to 40%. And wood primer, it will be having more pigmentation, that is pigment volume concentration, 35 to 40%. Let me further explain on the pigment volume concentration. So this is the low pigment volume concentration, and let me say this is the high pigment volume concentration. What do you mean by this? Assume that this is the paint vehicle, the medium. So here the solid part, the paint part is like this. The distance between the pigments dispersed here is greater. Whereas here it is very closer, much closer. That is, the pigment part is greater and the gaps are less. Are able to follow? So this is what called the pigment volume concentration, assuming that all these are pigment. Okay, so the concentration of pigment, it means the volume occupied by the pigment to the total volume. In this case is much less. Here it is more. So it means that is we have got more amount of pigment extended, and that is why if it is high gloss means it will be LPVC, that is low pigment volume concentration. If it is a matte means you can understand the pigment volume concentration is more, almost it is 50 to 70%. Are you able to follow this concept? Okay, so this is called pigment volume concentration. And we should know something about the weight, the specific gravity or the density of the paint. See, that is all ingredients will be in terms of weight. So you have got the, let me consider the specific gravity of the paint. How to calculate this? Very simple. That is, take the weight of the paint. Okay, simply speaking, divided by the fixed volume of the paint. That's all. So this is given in ml. This is given in gram. So usually it is given in gram per ml. Okay. So that describes the specific gravity of the paint. And the viscosity of the paint is, it is the rate of flow of liquid or paint. Actually, you got a fourth cup, that is also called flow cup. It will be like this. There will be a small orifice. It is a fixed volume. So here you have to, that is, add the liquid, and you have to calculate the time taken to completely empty this small vessel. Okay, so this is called 4 cup B4. So we used to give in terms of, for example, say about 80 seconds like that, or 120 seconds in B4 cup B4. Likewise, we used to mention. Okay, so these are all the regular controlling parameters being maintained in any paint industry. Let us work out the pigment binder ratio of an oil bound paint with the long oil alkyd. Its solid content is 72% and it is taken 25 parts by weight. Solvent is taken as 13.3, wetting agent and dispersing agent 0.9, anti-settling agent 0.3. Then pigment, so these are all pre-mixed and ground, and we had to add anti-skinning agent. Now the pigment binder part is 25 into 72%. We have to consider the solid part only, so 72%. And similarly here it is available as solid only, so 60. Now what is the pigment binder ratio? The weight of pigment divided by the weight of binder as solid. So the weight of binder can be calculated using the solid content. So you can use this 25 into 72 divided by 100. So 25 into 72 divided by 100. So it means 18. So 18 is the weight of the binder, solid content of the binder, and this is 60. So we can calculate 18, that is 60 divided by 18. So 60 divided by 18. Okay, 60 divided by 18. So the pigment binder ratio is 3.33:1. So you can declare pigment binder as ratio 3.33:1. Okay, so this is the way you have to calculate the pigment binder ratio. Let us consider a white gloss paint based on all-kit resin system. Let me give you the components, its function and density, along with the amount present in the paint. Component, and let me explain the function of each component, then its density in gram per ml, and then the amount present in gram as weight. Solid part of all kit. The remaining 50% is used for made up or making up of the resin using suitable thinner. Thinner is the combination of solvent. So we have to consider only the solid part. So this alkyd acts as binder, and its density is nothing but mass by volume, that is weight by volume. So 0.91. So it means when I take 1000 gram, it will have 1000 volume, 1000 ml, it will have 0.91 gram. Okay. So that is 91 gram, 910 gram in 1000 ml of the solution. So that gives you 0.91 density. And so I have taken the weight as 60.1 in gram. And as the second part, the paint contains titanium dioxide, that is the white pigment, and it has the density 4.2 and 25.2 is the weight taken. And then we have other solvents. So the solvent is around, and its specificity is 78.78. It means I have taken 11.7 gram. And I have taken other additives. So that is 3 gram. Okay, so let us add all these. 1 plus 2, 3 plus 7, 10 balance 1, 4, 5, 10 balance 1, 2, 4, 6. So 100%. 100 is the total, the weight. Okay. Now, for the calculation purpose of that is pigment volume concentration and the pigment binder, let us ignore the additives because it occupies the very least portion. So for the total 100 grams of the paint, the titanium is that is 60, is it not? 60.1. So we are interested to find out the volume. So how to calculate the volume of this one? Now, weight by volume. Density is equal to rho, that is density is equal to weight by volume. So we are interested in calculating the volume, therefore W by rho. So we are going to calculate the volume of the pigment. Okay. let us call it VP, that is volume of pigment, that is VP. So the VP is equal to the weight of the pigment divided by the density of the pigment. Here the weight of the pigment is 25, is it not? 25.2 gram divided by density. Density of the pigment is 4.2. Let us say 4.2. So gram per ml. Okay. So now let us work out 25.2 divided by 4.2 gives 6.00 we can take. So 6.00 and a gram can be cancelled. Now it is in ml. So volume of pigment is equal to 6 ml. This can be given in cubic centimeter also, because 1 cc is equal to 1 ml, that is 1 cubic centimeter is equal to 1 milliliter. Okay, and it doesn't contain any filler, is it not? So the volume of filler is nil here. Okay, and then let us go ahead with the volume of the binder, VB, that is volume of the binder. So what is the formula? We already know, that is the density is equal to weight by volume, therefore volume is equal to W by D. So here VB is equal to, that is the weight of the binder divided by the density of the binder. So that is equal to, weight of the binder is, we have taken 60.1 gram. So 60.1 gram divided by density is 0.91. Okay, 0.91. So in that case we had to consider the pure alkene. Okay, so if we go like this, so if we go like this, it will lead to a problem. Why? Because this is 50% solid as resin. So in that case you have to consider only the solid content. It means the weight, the solid content of the resin is equal to 50%. So when I take 60.1, I have to consider 50% of the solid only. Therefore 60.1 divided by 2, is it not? 60.1 divided by 2. So I have to consider only 30.05 as the weight of the binder, solid binder. Okay, and the density I cannot take this one, so I should approach the that is supplier and ask him the density of the resin. Usually it is given in the range of say 1.1 gram per ml. Okay, so the density of pure alkyd resin is 1.1 gram per ml. So this is the normal density of any all pit system. Okay, so in that case I have to use only this density. Now we can once again calculate volume of binder is equal to the weight of resin. Weight of resin we have calculated 30.05 divided by, you have to consider this density only, not this density. So 1.1 gram per ml, and this is gram. So you can cancel. Now you have to calculate the 30.05 divided by 1.1. That gives 27.32. Okay, 27.32 ml. Do you understand? So this is the volume of binder. So we have calculated two important aspects. One is volume of the pigment, another is volume of the binder. Based on that we can obtain the pigment volume concentration. Okay, so what is the pigment volume? The pigment volume is 6 cubic centimeter. Is it not 6 cubic centimeter? And what is the pigment volume binder volume is 27.32 cubic centimeter. Okay, now you can work out the PVC. Now what is the formula for PVC? The formula for PVC is volume of pigment plus volume of other extenders or fillers divided by volume of pigment plus volume of fillers plus volume of binder into 100, and this is given as percentage. So here VF is equal to 0 because it doesn't contain any filler. Therefore we can further modify the formula as VP divided by VP plus VB into 100. So this is the final formula. Now we will work out the pigment volume concentration. What is the pigment volume? 6 ml divided by 6 plus 27.32 into 100. Okay, so it means 600 divided by 33.32. So that is equal to, let us work out, 600 divided by 33.32. So it means 18.01%. So 18.01%. So this is the pigment volume concentration of this paint, white paint, that is 18.01%. So this is the way you had to calculate, and based on the percentage you will come to know that it belongs to gloss paint category. Do you understand? So this is the way you have to calculate the pigment volume concentration. Okay. So usually for high glossy paints it ranges from 15 to 25. So this is 18. Therefore this belongs to high glossy white top coat. Okay. The volume solids of a paint is a very good measure of the paint's quality compared to the another brand. So this is a very important term used to determine the quality of a paint. For example, this can be simply called VS, volume solid. This is usually represented in terms of percentage. So volume solid is equal to, it is given by this equation. Volume solid is equal to, that is volume of pigment plus volume of the binder. When I say binder, it represents the solid binder. So let me call it VB is the volume of